right, so test is tomorrow on 9.1 through 9.4. So we have the hyperbolas, ellipses, parabolas, and the parametric equation. So graphing and eliminating the parameter. Test is going to be 13 questions. 10 of those 13 questions are multiple choice. So with the multiple choice questions, I would say work smarter, not harder. Figure out which ones match your answer without kind of working out the whole thing. So you don't have to find everything, just see what matches and move on from there. Because remember, the quiz was like 7 questions and it took almost the whole class. So this is double the amount of questions, but just work smarter with the multiple choice. Let's take a look at number 2. So here we have a parabola. First thing we want to do is we want to get the squared part all by itself. So I'm going to divide by -1 on both sides. So we have y minus 6 squared equals -8 times x minus 7. So our vertex of our parabola would be what? Awesome, 7,6, because 7 is with the x, so that would come first. 6 is with the y, so that would come next. So I can graph that. We're going to go to the right 7 and up 6. So we've got a point there. Which direction is our parabola going to open? Since it's y squared, we know it's either going to be left or right, and since P is negative, we know it's going to be which way? Left or right? Left. So P negative means it opens to the left. Really, we didn't do any math here. We didn't find a whole lot of information. We just know that because it's y squared, it opens either left or right, and because P is negative, it's going to be left. That would probably be enough information to pick our answer choice right there, knowing which direction our graph opens. But let's just find everything else. Let's find our focus and our directrix. So the coefficient here, -8, is equal to 4p. To solve for p, we need to divide both sides by 4. So p is equal to -2. So p is the distance from the vertex to the focus. So I'm going to go to the left 2. Remember, your focus is always going to be inside your parabola. Like if your parabola was a bowl and your focus was an apple in that bowl. So our point for our focus is going to be, we went to the right 5 and up 6. So 5, 6. And then our directrix would be to the right of our vertex. And then we'd put a line through there. So is our directrix x equals or y equals? X equals, because it touches the x-axis. X equals what? X equals 9. And then one more, we can find our axis of symmetry. Axis of symmetry just connects the focus and the vertex. So this would be y equals, and y equals 6. We want to write the equation of the parabola in standard form with the given information. So our vertex is 0, 0, and our focus is 5, 0. So let's graph it. Our vertex is at 0, 0. Focus, we're going to go to the right 5 and stay at 0. So which direction is our parabola going to open? It opens to the right. And if it opens to the right, is it x squared or y squared? Y squared. Y squared is either left or right. So we have y squared equals 4p times x. We need to find what our p is. P is the distance from the vertex to the focus, which is 1, 2, 3, 4, 5. So y squared is equal to 4 times 5x. And since it opens to the right, is p positive or is p negative? Positive. It opens in the positive direction, so p would be positive. So y squared equals 20x. This would be our equation. We're not adding anything to the x or y because our vertex is just 0, 0. But if our vertex was something different than 0, 0, don't forget to add that h and k in there. One of the most common mistakes that people made on the quiz was that they just put the standard vertex at 0, 0 equation for everything, even though our vertex wasn't at 0, 0, or our center of ellipse was not at 0, 0. So don't forget the difference between when our center or vertex is at 0, 0 and when it's not. Good here? Perfect. Let's look at number 8 on the next page. So here our vertex is at 4, negative 5. So let's graph that. We're going to go to the right 4 and down negative 5. And then our directrix is x is equal to negative 1. So I'm going to go to where x is negative 1 and put a line through there. Which direction is our parabola going to open? Up, down, left, or right? Remember, it opens away from the directrix, so it's going to open to the right. Perfect. And if it opens to the right, is it x squared or y squared? Y squared. So here, because our vertex is not at 0, we actually have a point for our vertex. It's going to be y minus k squared is equal to 4p times x minus h, where our vertex is our h and k. And p is the distance from the vertex to the focus or from the vertex to the directrix. Remember, they're equidistant. So I go 1, 2, 3, 4, 5. Actually, just 4. 1, 2, 3, 4, 5. Yeah, we go 5. So p would be 5. Since our graph opens to the right, is p positive or is it negative? P is positive. Our graph's opening in the positive direction, so p would be positive. So let's plug everything in now. We have y plus 5, because minus negative 5 would turn into plus. So y plus 5 squared is equal to 4 times 5. So 4 times 5 would be what? 20. Times x minus h, which is 4. So x minus 4. So that would be our equation. Next, for 10, we're going to graph the ellipse, find the center, vertices, and foci. What is the first thing I need to do for number 10? Awesome. We need to divide everything by 2. It has to equal 1 before we can find what our A and B is and everything else. So you can either divide by 2, or if it helps with the math, we're multiplying everything by 1/2, because that would change this to be 1. If I multiply by 1/2 and multiply by 1/2 here, it might be a little bit easier to see. I think a lot of people, when they were dividing, got mixed up with the keep, change, flip, so their values were off. So here our new equation is x minus 1 squared over 36 plus y plus 4 squared over 16 is equal to 1. Now that it's equal to 1, we can find everything we need. What's our center? Perfect. 1 comma negative 4, so I can graph that. We're going to go to the right 1 down to negative 4. Next, what's our A? A squared would be 36 here. So A is 6, perfect. And B squared is 16, so just B would be 4. How do we find C here? C squared equals what? A squared minus B squared, perfect. When it's an ellipse, it's A squared minus. So if the equation has a plus in it, the equation for C is going to have a minus. If our formula or our equation of a hyperbola has a minus in it, then to find C squared, it'll have a plus. So it's always the opposite of the original equation. So here, C squared equals 36 minus 16 So c squared equals square root 20. We want to simplify square root 20, so our factors would be 4 and 5. So c equals 2 square root 5. We can approximate our square root here just to help us graph it. Square root 20 is a little bit less than square root 25, so square root 25 is 5. We can call this 4.5, just to help us graph. But remember, if this is multiple choice, you may not even have to do this much math to graph it all. So let's find our vertices next. So our vertices, for our major axis, we're going to use A. Since A came from under the X, that means that we go left and right 6. So we're going to go to the left 6 and to the right 6. So my points for my vertices, I can just look at my graph, or we could add and subtract 6 to the x. So we would get 7 comma negative 4 and negative 5 comma negative 4. Next, we can find our co-vertices. Co-vertices, we look at the B. Since B came from under the Y, we're going to go up and down 4. So from the center, I'm going to go up 4 and down 4. I can look at my graph and just figure out what points those are, or we could add and subtract 4 to the Y. So we get 1 comma 0 and 1 comma negative 8. So here would be our ellipse. One more thing that we have to put on it is our foci. Which way would the foci go? Up and down or left or right?
Up and down.
It'd go, no, left and right. Because foci are always on the major axis. So they're also going to go left and right because our major axis, the longer axis, is horizontal here. So I'm going to go to the left and the right, 2 square root 5, which we said is about 4.5-ish. So I'm going to go to the right 4.5-ish and to the left 4.5-ish. So our foci, we can't just use 4.5-ish because we kind of made that number up, but we have to use 2 square root 5. So since I moved left and right, I'm going to add and subtract 2 square root 5 to the x from my center. So it'll be 1 plus or minus 2 square root 5, comma, negative 4. So here we're going to graph the hyperbola, find center, vertices, foci, and asymptotes. So before I can do anything here, what should I do first? You need to multiply everything by 2. So that'll cancel out. So then we just have 1 on the right side, which is what we needed. In our first fraction, we have 2 over 32, which would simplify to what? 1 over 16. Minus, in our second fraction, we have 2 over 50, which would simplify to what? 1 over 25. That's equal to 1. So because it has a minus sign in the middle, we know it's going to be a hyperbola. In our hyperbolas, A is always the one that comes first. So a couple of things we know from here. I'll just label it now. A squared is going to be 16. So what's A? 4. B squared is 25. So what's B? 5. Perfect. To find C, what do we do? Awesome. C squared equals A squared plus B squared. So because the equation has a minus in the middle, the C formula is the opposite, so it'll have a plus. So C squared equals This would be 16 plus 25. So c squared equals 41. So c is square root 41, which we can't simplify. So we're just going to leave it as square root 41, which is about, it's less than the square root of 49, which is 7. So we can call it 6.5-ish. So this is just to help us graph it, but the official number for it is square root 41. All right, let's look back at our question here. Where would our center be? Awesome, -1, 2, perfect, because the 1 is with the x and the 2 is with the y. So -1, 2, we can graph that. Let's go to the left to -1 and up 2. Is this going to be horizontal hyperbola or vertical hyperbola? Vertical. So since our y comes first, and since the a is under the y, remember a always comes first, but since the y comes first, it's going to be a vertical. So our transverse axis is going to be vertical, and our hyperbolas are going to be vertical. So we're going to go up 4 and down 4 because a is 4. Those are going to be our vertices. So I went to -1, this is 6, and -1, -2. Our co-vertices are going to go to the left and to the right. So we're going to go to the right 5 and to the left 5. So my co-vertices would be at 4, 2, and 6, 2. Next, we want to draw our asymptotes. -6, 2. Yes, you are right. -6, 2. Perfect. We want to draw our asymptotes, so I'm going to draw this imaginary box that connects the vertices and the co-vertices. And then through the diagonals of our box, we're going to have our asymptotes. And then we can draw our hyperbolas, kind of hugging the corner of our asymptotes there. So they look like that. We can put our foci on our graph too. So C is the distance from the center to the foci. So we said C was about 6.5-ish. So I'm going to go from the center up and down 6.5. So our foci would be about there. Since we went up and down for our foci, we will add and subtract it to the y in our center because we went up and down. So we're going to add and subtract square root 41. So my foci is going to be -1, 2 plus or minus square root 41. And then lastly, let's write our asymptotes. So our formula for our asymptotes is going to be y equals k plus or minus. Now it's either a over b or b over a. When it is a vertical hyperbola, what do we think? Joy, what do we think? A over b, perfect. Times x minus h. So let's just plug everything we have into our asymptote formula. So y equals k comes from our center, so that is 2 plus or minus. A is 4 over b, which is 5, times x minus h, so x plus 1. So it gives us the covertices here, so let's graph. We're going to go to the right 3 and down to negative 2, and then to the right 7 and down negative 2. So these are our covertices. What would the center be? It'd be the midpoint of them. So our center would be, bless you, 5 comma negative 2. The distance from the center to the covertices, is that A or B? What do we think? It would be B. So B is equal to 2. We don't know what A is yet, but we do know since the covertices are horizontal, that means our vertices would be vertical. So in a vertical hyperbola, what comes first, the x or the y? The y would come first. So we have y minus k squared over a squared, because for hyperbolas, a always comes first. For ellipses, a is always the bigger number. Minus x minus h squared over b squared is equal to 1. So we know what b is, we can plug that in, and we know what h and k are, so we can plug those in. So b, we said, is 2, so b squared would be 4. H is 5, so we have x minus 5. And k is negative 2, so y minus negative 2 would turn into a plus 2. So now we just need to find a. Hopefully if this was an answer choice, or if this was a multiple choice question, maybe this would be enough to find your answer choice and you wouldn't even have to figure out what a is. But we're going to find it. So we're going to use our asymptotes. Our slope helps us find what a is. So our slope is 5. When we have a vertical hyperbola or vertical transverse axis, is it a over b or b over a? A over b. So 5 is equal to a over b. And what did we say b is? 2. So we can plug in 2 into our b. And then when we solve for a, we're going to multiply 2 on both sides. So what does a equal? 10. So what is a squared? 100. Perfect. So this would be our answer. So we want to eliminate the parameter and graph. I'm going to graph it first and then we'll eliminate the parameter. So I'm going to make my table to graph. We have our t, x equals, y equals, and our point, x comma y. So our point is what's going to end up going on the graph. What am I going to plug in for t here? It gives us -1 to 4. So we want to plug in all the values from -1 to 4. So we have -1, 0, 1, 2, 3, and 4. So my x equals equation is -t plus 9. My y equals is 5t squared minus 5. So starting with -1, we're going to plug in -1. So -1 would turn into +1 plus 9, which would be 10. So our x and our point is 10. Our y is going to be -1 squared, which is, here, I'll write it out so we can see it plugged in. -1 squared, which is 1 times 5 would be 5, minus 5 is 0. So our y would be 0. I'm going to plug in all of our points, and then we're going to graph it at the end. So next, let's plug in 0. We have 0 plus 9 would be 9. And then 5 times 0 squared minus 5 this would be negative 5. Then we plug in 1, we get negative 1 plus 9 would be 8. And then 5 times 1 squared minus 5 would be 0. Then we can plug in 2. We have negative 2 plus 9, which would be 7. So our x is 7. Our y would be 5 times 2 squared minus 5. So 2 squared would be 4. 4 times 5 would be 20. Minus 5 is 15. Then we can plug in 3. We have negative 3 plus 9, which would be 6. So our x is 6. Then we have 5 times 3 squared minus 5. 3 squared is 9 times 5 would be 45. Minus 5 is 40. And then lastly, we can plug in 4. So negative 4 plus 9 is 5. So our x is 5. And then 5 times 4 squared minus 5. 4 squared is 16. 16 times 5 is 80. 80 minus 5 would be 75. Yes. So now we want to graph this. I'm going to make my margins on the y-axis go up by 5 just because our numbers get really big. Actually, I'm going to make them go up by 10 because our numbers get super big. So I'm going to say this is 10, 20, 30, 40, 50, 60, 70. And then I'll keep our margins on our x-axis just going up by 1. So it's super important that we plug it in order, because in order to graph our parametric equations here, we need orientation. We need direction. So starting with the orange point that we found when t was negative 1, our point is 10, 0. So I'm going to go to the right 10, stay at 0. Then our next point was 9, negative 5. So we're going to go to the right 9 and down to negative 5. Then our next point was 8, 0. So we're going to the right 8, stay at 0. Then our next point was 7, 15. So I'm going to go to the right 7 and up 15. Then our next point was 6, 40. So I'm going to go to the right 6 and up 40. And then 5, 75, we're going to go to the right 5 and up 75. Then we want to connect all of our points in order. So we started with the orange one, went to the pink, the blue, the teal, the black, the purple. And then we need to show our orientation. So I went from the orange to the pink, pink to the blue, blue to the teal, teal to the black, black to the purple. So make sure you draw your arrows. So this would be our graph. So on your graph, you need to show your orientation. Any questions with our graph there? Next, we're going to eliminate the parameter. So I'm just writing our x and y down here at the bottom. Which equation do you think would be easier to get t all by itself? The x equation. So let's solve for t in our x equation. We can subtract 9 on both sides. So we get x minus 9 is equal to negative t. what would we do next? Divide by -1. So we would get t equals, turns into a +9 and a -x, so 9 minus x. What would I do next? I'm going to take what t is equal to and substitute it into the t in my other equation. So I have y equals 5 times 9 minus x squared minus 5. We can simplify this. 9 minus x squared would be 9 minus x times 9 minus x. So we would have to FOIL. So we get 5 times 81 minus 18x plus x squared. I'd have to distribute the 5. 81 times 5 would be 405. Minus 18 times 5 would be 90. So 90x plus 5x squared minus 5. And then just combine our like terms. So 405 minus 5 would be 400. So y equals, I'm going to put it in standard form, 5x squared minus 90x plus 400. So that would be our equation. If you made the y equals equation, t, if you solve for t in that one, you'll end up with a different looking answer. It's going to be the same, but it'll just look different. In the answer key, we worked it out both ways. So if you did it with the y equals equation, made t equal with your y, and then substituted it in the other way, your equation is just going to look a little bit different, but that's fine. We worked it out both ways in the answer key. So you could check your work there. Any questions about the tests tomorrow?